Welcome to my presentation on earthquakes. I'm thrilled to have you join as we embark on a journey to explore the captivating world of seismic activity. Earthquakes, as you may know, are some of the most powerful and awe-inspiring natural events on our planet. They remind us of the dynamic forces that work beneath the Earth's surface and the incredible energy that shapes our world. Throughout this presentation, I will take a deep dive into the science behind earthquakes, explore their causes, their effects, and in ways in which they can impact and improve our lives and our environment. We'll also discuss the latest research and innovations in earthquake monitoring, as well as prevention. But more importantly, I just want to make an understanding of the science to foster a greater appreciation and awareness of earthquakes and their significance in our world. Whether you're a seasoned geologist, a citizen, or someone just curious about earthquakes, there's something here for everyone. So without further ado, let's dive into the fascinating world of earthquakes and discover what lies beneath our feet. Let's start with an overview of what we'll be covering today. First, we'll dive into the background of earthquakes, exploring the science behind these natural phenomena and the occurrence across different regions of the United States. After that, we'll examine the magnitude and aftermath of earthquakes themselves, discussing the scale of destruction they can cause and the long-term consequences for affected communities. We'll also take a deep dive into the frequency history of earthquakes in the United States, and we'll analyze trends over time and understanding how often these seismic events do occur. And finally, we'll explore the geographical probability of earthquakes, mapping out high-risk areas and discussing the factors that contribute to their likelihood. So let's buckle up as we embark on the journey through seismic activity in the United States, from understanding the science to assessing the risks and impacts. Let's begin. An earthquake is a sudden release of strain energy in the Earth's crust, resulting in shaking waves that radiate outwards. Let's dive into the heart of the matter. What is exactly an earthquake? At its core, an earthquake is the sudden release of strain energy that's built up within the Earth's crust. This energy accumulates over time as tectonic plates pieces the Earth's lithosphere, and they grind against each other, they collide, and they slide past one another along fault lines. Imagine the Earth's crust as a jigsaw puzzle made up of these plates. As they move, they can get stuck against each other due to friction. When the stress at the edges of the plates overcome this friction resistance, the rocks break or slip suddenly, releasing a ton of energy in the form of seismic waves. These seismic waves travel through the Earth, causing the ground to shake. There are three main types of seismic waves. First, primary waves, or most knownly as P waves. These are the fastest seismic waves and travel through solid and liquid rock, causing back and forth motion. Secondary waves, or S waves, move slowly, and they move more slowly than P waves and travel only through solid rock, causing a side-to-side motion. Surface waves, these waves move along the Earth's surface and are responsible for the most severe shaking and damage during an earthquake. The intensity and duration of shaking can cause and vary depending on several factors, including the magnitude of the earthquake, the depth of the earthquake's focus, and the distance from the epicenter. Earthquakes can range in size from barely perceptible tremors to catastrophic events that can cause widespread destruction and loss of life. Understanding the nature of earthquakes is crucial for preparedness and mitigation efforts, as we'll explore further in the following slides. The Pacific Ring of Fire, Alpine Belt, and Mid-Atlantic Range are the three most common earthquake hotspots in the world. Now let's take a global perspective and examine the three most common hotspots. First, the Pacific Ring of Fire. This horseshoe-shaped region encircles the Pacific Ocean and is notorious for its high seismic activity. The Ring of Fire is characterized by intense tectonic activity, including subduction zones where one tectonic plate is forced beneath another, leading to powerful earthquakes and volcanic eruptions. Countries bordering the Pacific Rim, such as Japan, Indonesia, Chile, and the western coasts of North and South Africa, are vulnerable to earthquakes and volcanic activity due to their proximity to this zone. Second, the Alpine Belt. It stretches from the Mediterranean region through the Himalayas. It's another major earthquake hotspot. This belt marks the collision zone between the Eurasian plates and the African, Arabian, and Indian plates. The collision and convergence of these plates have resulted in the formation of mountain ranges such as the Alps, the Himalayas, and the Zagros Mountains. The seismic activity in these regions is primarily caused by the compression and uplift from the Earth's crust along these collision boundaries. The Mid-Atlantic region and ridge, unlike the other two hotspots, is underwater mountain range that runs from the center of the North Atlantic Ocean. It marks the boundary where the North American plate and the Eurasian plate are moving apart, leading to seafloor spreading and volcanic activity. While earthquakes along the Mid-Atlantic Ridge tend to be less frequent and intense compared to those in the Ridge of Fire, the Alpine Belt, they contribute to the overall seismic activity of a global scale. Understanding these major earthquake hotspots is crucial for assessing global seismic risk and implementing effective disaster preparedness and mitigation strategies in these extremely vulnerable areas. All earthquakes operate on a magnitude scale, which denotes the strength and implications for destruction. Now that we've explored where earthquakes occur, let's dive into how they measure their strength and the implications for destruction. All earthquakes operate on this magnitude scale. The two most commonly used magnitude scales are the Richter scale and the moment momentum scale, which is the MW. The Richter scale, developed by Charles F. Richter in 1935, measures the amplitude of seismic waves recorded by seismographs. It's a logarithmic scale, meaning that each whole number increase represents a tenfold increase in amplitude and proximity, 31.6 times more energy release. For example, I know that is confusing. A magnitude of 7.0 releases 31.6 times more energy than one with a 6.0. While the Richter scale is still reinforced and referenced, it's less commonly used in the modern seismology. The moment magnitude scale, or the MW, is used today mostly. It calculates the seismic moment of an earthquake, which takes into account the area of fault rupture, the average amount of slip, and the rigidity of rocks involved. The moment magnitude scale provides a more accurate representation of earthquake size, especially for those with large regions that occur at great depth. Regardless of the magnitude scale used, earthquakes of higher magnitude generally result in more severe shaking and greater potential for destruction. However, the effects of an earthquake also depend on other factors such as the depth of the earthquake's focus, the distance from the epicenter, local building codes, and popularity and population density. Understanding earthquake magnitude is essential for assessing those risks and also finding yourself in a position to be successful and safe. Natural disasters and hazards such as avalanches, floods, fires, landslides, and tsunamis are all derived from earthquakes. Avalanches in mountainous regions, earthquakes can be destructive snowpacks leading to avalanches. The shaking can release triggers for large masses of snow, ice, and debris to fall. Fires, they can rupture gas lines and damage electrical systems, increasing fire probability. Floods, they can rupture dams, levees, and water disruption systems, resulting in flooding nearby. Landslides, the shaking of ground and movement, generate earthquake, can just stabilize slopes leading to landslides. And tsunamis, perhaps one of the most devastating consequences of undersea earthquakes is the generation of tsunamis. These massive ocean waves can travel thousands of kilometers across the open sea, striking coastal areas while tremendously forced and causing widespread flooding, destruction, and loss of life. Smaller earthquakes happen often, daily worldwide. Major quakes, 7+, often occur monthly, and great earthquakes happen yearly. The graph here below shows that Walter, California actually experienced the most earthquakes in a specific community in the United States. Walker, California is a small, unincorporated community located in Mono County, nestled in the eastern Sierra Nevada mountain ranges. Known for its scenic beauty and outdoor recreational opportunities and activities, Walker offers access to nearby and natural attractions such as the Hoover Wilderness and the Bridgeport Reservoir. The area is popular among outdoor enthusiasts for activities such as hiking, fishing, and camping. Rounded magnitude breakdown shows consistency in experiencing minor to mild earthquakes frequent. Minor to mild earthquakes are commonly occurrences in the United States due to its geographical activity. With the vast network of fault lines, particularly along the Pacific coast, tremors are felt regularly throughout the country. These quakes, often measuring between 0 to 3 on the Richter scale, may cause light shaking and minimal damage. While most people don't even notice them, they're still a reminder of the dynamic nature of the Earth's crust and the ongoing seismic activities. Earthquakes with a magnitude of 5 or more, on average, there are several hundred earthquakes between the 5 and 5.9 range. However, these frequencies can vary depending on region seismic activities. The United States, for example, along the Pacific Ring of Fire, which includes California, Alaska, and the Pacific Northwest, earthquakes of magnitude 5 or more are common due to the tectonic associated with the Pacific plate boundary. While these earthquakes may cause noticeable shaking and minor damage, they are generally not considered to be seismic events. As we consider the future of seismic activity in the United States, it's crucial to understand the forecasted earthquake risk. Research and analysts conducted a seismologist and geologists indicate that nearly 75% of the U.S. could experience a damaging earthquake in the next 100 years. Various factors contribute to this forecasted risk, including the complex tectonic settings across different ranges of the country. While some areas, such as the Pacific Northwest and California, are well known for their high seismic activities, but low magnitude scale, are deemed at higher risk. It's essential to recognize that earthquakes can occur unexpectedly in regions that are not traditionally associated with a significant seismicity. Understanding and preparing for this forecasted earthquake is essential for enhancing our resilience and being ready for property damage. Through proactive measures such as strengthening building codes, using early warning signs, and educating the public, we can fight ahead. The largest recorded earthquake in the U.S. was a magnitude 9.2 that hit Prince William Sound, Alaska in 1964. On March 27, 1964, a massive magnitude of 9.2 struck South Alaska. This earthquake, known as the Great Alaskan Earthquake, remains the largest recorded earthquake in U.S. history. The earthquake generated powerful seismic waves that propagated across vast distances, triggering landslides, tsunamis, and widespread ground shaking. The impact of the 1964 earthquake was immense. It caused major damage to communities, infrastructure, and landscape across Alaska, with effects felt as far away as California. The tsunami generated the earthquake resulted in devastating coastal indications and loss of lives. This historic earthquake serves as a stark reminder of the immense power and destructive force that these seismic events can have. And lastly, advancements is raising awareness, it's strengthening building codes, and developing warning signs to practice preparedness. As we look ahead into the future, it's clear that earthquakes will continue to happen. However, embracing proactive measures and building resilience, we can mitigate the impact of these seismic events. First and foremost, it's important to educate and raise awareness. It's important to strengthen those building codes, develop those early warning signals, and build community networks. If we practice preparedness, we can conduct regular drills, exercises, simulations to practice earthquake response and recovering procedures. By taking these proactive measures, we can invest in resilience. Let's work together to rebuild the resilient communities, strengthening infrastructure, and protect our lives from these seismic challenges. Together, we can make a difference.